Because, so what would be the reason not to give up? Because now we can find distance between parallel lines, for example. That is one of the problems. So, can you tell me, well, if I give you two equations, can you tell me if the equations define parallel lines or not? Let me give you two equations. 2x minus, no, it's not good. That's okay. 2x minus 4y equals 7 and negative 3x plus 6y equals 5. Can you tell me if these two equations describe the same line? Yes, they describe the same line. They're probably doing heavy-duty computations.
No, I multiplied first equation by negative 1.5, and I got second equation.
So you multiplied the first equation by negative a half?
No, negative 1.5.
Negative 1.5, negative 3 halves. All right. And that gives you what? Negative 3x. Right, multiply minus 4 by negative 3 halves gives you plus 6y, and that multiplied by this number is minus 21 over 2. So you manipulated that equation in a very simple way to get what? Well, to make it look like that equation. But is it the same equation?
It shifted a little bit.
It shifted, so
same line.
most of it looks the same, but the constant is different. And that constant is exactly about the distance. And what you can see now is that well, let me do sort of the same geometrically. I will look at the vector 2 minus 4 perpendicular to the first line. I will look at the vector minus 3, 6 perpendicular to the second. And the lines are parallel if and only if the perpendicular vectors are parallel. And can you tell me if these two vectors are parallel? What does it mean algebraically that two vectors are parallel?
They're multiple to each other.
Multiple to each other. They're proportional. Can you see a number so that you can multiply this vector by a number to get this vector? Well, negative 3 halves, right? So if the vectors are proportional, then the lines are parallel, but of course those are different lines. And now it makes sense to ask about these two lines, what the distance is between them. And here's the way to find that distance. Imagine the coordinate system, and see what we can figure out from that meaning of c, of that free constant, is we can find quickly the distance from the origin to the first line, and also the distance from the origin to the second line. And what do we do with those? What's going to be the first distance? Now let's say this is the first line, number 1, and that is the second line, number 2. And of course, I created a picture without even thinking about numbers, so this picture might not correspond to what algebra says. The lines may not look like those two in this coordinate system, but let's pretend they are like this. So for the first line, the distance from the origin, okay, let's first agree that finding distance from origin to these two lines helps to find the distance between the lines. Does it help? How would you find it?
The component. Use the component.
Well, you see, you know this distance, you know this number already,
Oh yes.
and you know that number already.
Distance.
What's the distance between the lines?
The square root of sum of squares.
The big one is the small one.
You were, yeah.
Well, the difference.
Yeah.
Right. So the distance from origin to the first line is going to be 7 over magnitude of the vector 2 minus 4, square root of 2 squared plus negative 4 squared. And the distance to the second line is going to be 5 divided by square root of negative 3 squared plus 6 squared. Okay. So what should we do? Subtract the two numbers and hope that that's the distance. Is it the distance? So 5 over square root of 9 plus 36 minus 7 over square root of 4 plus 16.